Now, we are being recorded, and this will be posted to Riot's YouTube channel and uploaded to the meetup page where you registered for this event. If you have any questions throughout the chat, I will be monitoring the chat box and we'll let the audience know if they will be answering questions during or after the event. Please keep yourself muted throughout the event, and I will be monitoring everyone for making sure we keep muted because that's good Zoom etiquette. So, Brian, do you prefer questions during or after the event, or do you not care?
Oh, let's see. I actually don't care. I would say if someone gets kind of hung up on something, you know, and like kind of can't focus until they get a question answered, you know, please ask during. I don't want to leave anyone behind, especially if maybe I misspoke about something and we need to clarify before going on. But if that's not the case, I prefer if you keep, you know, write down your question, kind of keep it to the end. Yeah.
Okay, sounds like a plan. Well, I will be monitoring the chat box for everyone's questions. So, Brian, I will turn it over to you, and I will be sitting here in the background.
Awesome, thanks, Jen. Super appreciate it. And hey, good to see such an awesome list of attendees today. I mean, thank you guys so much for joining. You know, hopefully the title of the Lunch and Learn today is more than just clickbait. Although I do have to qualify, it might not be everything you need to know to be successful, but definitely most of the most important stuff you need to know to be successful with LoRaWAN. So I want to, just acknowledge there are some key LoRaWAN players in the audience today. So and fellow members of the LoRa Alliance. So hopefully I'll do the technology proud. But thank you again for joining, for taking your lunch hour with me. Just a quick introduction. I'm Brian Bielawski. I'm the Vice President of Product here at CalChip Connect. And a few words about myself. I joined the LoRa Alliance the year after it started, you know, which was circa, I think, 2016 is when I joined. The Alliance was started in 2015. So I have a pretty good history with LoRa and LoRaWAN deployments. One of my first assignments at the first IoT company I started to work for was working with Semtech. We'll talk a little bit more about Semtech later, the creators of the LoRaWAN technology, to help them help the ecosystem bring full stack solutions to the market. My first role, I was at an IoT platform company focused on the software side. Then I moved to an IoT manufacturer to focus on the hardware side. And now I find myself kind of in a perfect combination of the two. I'm at an IoT distributor, and we combine both the hardware and software. So hopefully I have you know, enough credibility to talk intelligently about the subject of LoRaWAN and hopefully to impart some really useful knowledge to you today. So a brief background about CalChip Connect. We have 37 years in the electronics distribution industry. CalChip Connect started as the IoT division of a larger company called CalChip Electronics. And then 2 years ago, we spun CalChip Connect out. It was kind of taking off and ready to stand on its own. So we're our own entity now. We've shipped over 100,000 IoT gateways worldwide, and then a broad line of IoT solutions running over those networks. We have over 45,000 customers, which is a combination of individuals, you know, SMBs and enterprises. But we work with a lot of tier 1 OEMs. Sorry, forgive me if I didn't say this. We're a distributor. We're a technology distributor. So we represent, you know, quite a few, you know, close to 100, 120 OEMs on our line card, including the ones that you see on the screen there. We tend to bundle kind of disparate market technologies. We're one of the companies leading the charge in bringing blockchain and cryptocurrency together with Internet of Things and LoRaWAN technology. So we can talk a little bit more about that later and the intersection of those technologies. We have a provisioning department where we're able to provision solutions before they ship. In most cases, we're drop shipping directly to the end customer on behalf of our customers, who are generally system integrators or solution providers of some sort. We support and we help build some of the fastest growing IoT networks in the world. And I love the phrase, we have omni-channel experience, meaning that we have a customer base that is both consumers and businesses. So today's agenda for this Lunch and Learn, we'll focus at a high level, what is LoRaWAN, and talk quickly about the difference between LoRa and LoRaWAN. We'll go over why one would choose LoRaWAN, talk about some common slam dunk applications for the technology. We'll go over the key players in the ecosystem. How does one design a LoRa solution? What are the pitfalls? I'll share one kind of a great example use case for designing and launching a new LoRaWAN solution. And then just some parting wisdom about if someone's interested in exploring LoRaWAN, some mistakes to avoid and some things to focus on. I have to give credit to, and there's someone here from Semtech today, so I just want to thank Semtech for loaning me some of their slides that they use in some of their introduction to LoRa classes. So thank you, Semtech, for that. You'll see, slide courtesy of Semtech in the corner if it's one of theirs. Okay, let's get started. So as I mentioned before, LoRa technology was created by a company called Semtech. They're a semiconductor company based in California, Camarillo, California, with offices all over the globe. And so anytime you purchase or use a LoRaWAN sensor or a LoRaWAN gateway, it's Semtech's chips inside the gateway and their IP around LoRa technology. Just a bit about the architecture so we can draw the distinguishing line between LoRa and LoRaWAN. So LoRa, just L-O-R-A, which stands, if you haven't figured it out by now, it stands for long range. LoRa is the physical layer or the wireless modulation used to create the long range communication link. So another way to say it is LoRa is the term for the technology that's able to do very low power, long range, radio communication, and then some other, secret sauce in there that makes it that deals really well with interference and other RF concerns. And then on top of that physical LoRa layer, then is the LoRaWAN protocol, which is an open networking protocol that delivers secure bidirectional communication, mobility, and localization services. So again, said another way, it's just kind of like square rectangle. It's possible for someone to have a LoRa solution that's based on LoRa technology, but not leveraging the LoRaWAN protocol, in which case it wouldn't necessarily be interoperable with all the pieces of the solution stack, people who are leveraging the LoRaWAN protocol. So you'll see that in the market is some people design proprietary LoRa solutions, and those proprietary LoRa solutions don't play well with the broader LoRaWAN ecosystem and everyone using the open protocol. Just a quick comment here on these regional ISM bands. So depending on where you are in the world, different countries have different unlicensed spectrum that they've relegated to LoRaWAN. So here in the US, we're using spectrum between 902 and 928 megahertz, which we refer to as the US 915 band. In Europe, there's a center around 868 megahertz. There's another European one that's 433, and then in Asia Pacific, you're also in the 400s. And then there'll be little kind of tweaks to the spectrum used depending on where you are in the world. The reason I bring that up is because if depending on where you're deploying, and if you're a global company deploying LoRaWAN worldwide, then you will actually, sorry, I forgot to disable my notifications. Forgive me if you hear the little bleeps in the background. Depending on where you are in the world, you'll have to be knowledgeable about what frequency you need to deploy in. And if you're deploying a global solution, you might have different versions. One version for North America, one version for all of Europe. Not to get too deep in the weeds, but there is there's been an ongoing effort to make a LoRaWAN version using 2.4 gigahertz, kind of the universal unlicensed spectrum, wherein Wi-Fi and Bluetooth reside. So that does exist if someone's doing a truly global solution and just wants to have one SKU. But in general, to address different regions, you generally have different SKUs for each of the regions. And if anyone has if I didn't kind of capture that eloquently enough, or if that wasn't clear, feel free to ask a question. And then on top of the LoRaWAN MAC layer, that's where one would put their application, their actual specific application for their use case. All right, moving on. If you've ever dabbled in LoRaWAN, you've probably seen a million versions of this slide. But for those of you who are new, just to talk through the architecture at a high level, you've got on the left-hand side there, you see all the sensors. So these are generally battery-operated devices, although they might be powered. We'll get into that later. But generally battery-operated devices that are going in any number of places, kind of all over. They could be soil moisture sensors in a field. They could be sensors monitoring HVAC systems in a building. They could be temperature sensors in the refrigerator of a restaurant. They could be trackers strapped around the neck of a cow. So on and on and on, the use cases are endless. But on the left-hand side, you've got the sensors that are talking over the LoRaWAN protocol to a gateway or a series of gateways. So obviously, gateways receiving the information that the sensors are broadcasting, and then acting as that gateway to the cloud. So they're backhauling that data over, either Wi-Fi, Ethernet, or cellular to some network in the cloud. And granted, there are different architectures, and we'll touch on them later. But this is kind of the general setup for LoRaWAN. The data is going into a network server. That network server is then responsible for unencrypting the data and making sure that data gets to its proper end user. So it's passing that to an application server, which is then managing all the cloud IoT services that are serving as the front end or the customer facing end of the solution. So these are in general the four main components of a LoRaWAN solution. Throughout today, I'll refer to them as the pieces of the stack. And then obviously, just a little note here, this is all end-to-end secured. And part of the LoRaWAN protocol is the security that's gone into that the LoRa Alliance has put into the spec to make sure that people can't intercept messages or eavesdrop, or it's an extremely bulletproof, secure technology. So, why would one choose to deploy an IoT solution using LoRaWAN? Well, it's optimized to be low cost and low power. Because of the it's a star network topology, meaning it's not mesh or a different way of architecting. You've got in general one or a few number of gateways and the sensors are communicating to those. So there's generally not a lot of infrastructure needed to run a LoRaWAN solution. There's redundancy, meaning between gateways and sensors. So if a sensor, as it broadcasts its payload, if it's able to reach multiple gateways, those multiple gateways will then be passing the information up to the cloud where it's sorted out and gets where it needs to go and deduplicated and all that. So there's redundancy there. If one gateway goes down, chances are that sensor can see another gateway, and so that data is still getting where it needs to go. And because it's all an open protocol, there's no need to pair a device with a certain gateway. If you deploy a LoRaWAN gateway and it's in range of 1,000 sensors, it's going to hear the broadcast coming from those sensors without having to do like a device to gateway pairing. Obviously, the high radio frequency sensitivity enables lower transmit power, which means the battery life of the device is, in some cases, staggering. I would say, from my experience, the average battery life of a LoRaWAN device is somewhere around 8 to 10 years. Sometimes more, depending on how often it needs to transmit. Sometimes less if it's, maybe it's a GPS, asset tracker, which is kind of constantly pinging. But yeah, it's optimized for battery life. And then obviously, as I mentioned before, the security around LoRaWAN is watertight and really best in class when it comes to IoT. Just to talk about the features now of the network, many advantages that LoRa brings to the marketplace. We already talked about the range, but just to give you an idea, you'll find these things on the internet, these kind of freak range tests where someone had a LoRa gateway somewhere, up on a hill, and they received a packet from a sensor, 30 miles away. And although that's not always the norm, it's not unusual to get range like that. If you have optimal gateway placement, meaning that it's high up and not a lot of obstruction, you can see for miles and miles, and those sensors, you can receive the sensor data for miles and miles. This makes it extremely valuable for outdoor deployments, but also valuable for indoor deployments, because you're dealing with sub-gigahertz spectrum. The sensors are able to broadcast, through strongly through a variety of materials. So you can blast through floors and walls. I like to tell a story. I actually was involved in a LoRaWAN deployment at a banquet hall, and we put a temperature sensor inside of a walk-in freezer, which was inside of a walk-in cooler. And the gateway was deployed in the manager's office on the other side of this banquet hall. And we never missed a packet. So that sensor data could punch through, a lot of steel and then cover a lot of distance to reach that gateway. Hence my next bullet point: deep indoor coverage in multi-floor buildings. We talked about the battery lifetime. 10 to 20 years, not uncommon. And in general, it's over 10 times the battery life that you would be getting from a comparable cellular device. LoRaWAN is built for multi-usage, for high capacity. The goal of LoRaWAN and kind of where the entire technology is heading is millions of devices sending, multi-millions of packets a day to gateways, and then network servers that are sorting out those messages and getting that data where it needs to go. So extremely high capacity, obviously allows for multi-tenant interoperability, and also creates an opportunity for, similar to cellular, for companies to build public networks. And when we talk about the ecosystem, we'll talk about the public networks that are already in play. Chances are, assuming that most of you are in relatively urban areas or suburban, you're probably sitting inside of a LoRa network right now, or 2 or 3 public LoRaWAN networks that are available for you to use. You might not even be aware of it. And then we already talked about the cost factor. Because it's minimal infrastructure, so few gateways are needed. The end nodes are generally low cost, compared to something like their cellular counterpart. And then it's an open software stack, so anyone can design for LoRaWAN. There is no, licensing costs or anything like that. Excuse me while I clear my throat here. Pardon me, I couldn't find the mute button in time. All right, some more additional network features. So the LoRaWAN protocol is bidirectional, meaning that it's not just sensors broadcasting data, but you can also then communicate back to those sensors, not just to do things like firmware updates, but also to control things, to actually, control a valve or turn on a light or control a smart outlet. So communication is bidirectional. Excuse me. My son came down with a cold a couple of days ago, and I think I'm getting it. So the LoRaWAN standard, it's a global standard, allows for true mobility, although with that one caveat that I said, that when moving between different frequency regions, you're going to need to adjust for that. And because it's a global protocol, it ensures interoperability. You can pick up a LoRaWAN device, any LoRaWAN gateway, any LoRaWAN network server, and you can be assured that those parts of the stack are going to play well together. You might need a little bit of tweaking here and there, to optimize things, but in general, the different parts of the stack are made to all fit together in thousands of different combinations. The security we talked about, embedded end-to-end AES-128 encryption, and then there's a series of keys. So core to the secure element of LoRaWAN is that if you own a sensor, you have 3 keys that are given to you with that device that only the manufacturer knows, and even they have they don't really the records of those keys are not in many cases not directly visible to them. So you own the sensor, you own the keys. Without those keys, no one can unlock the data that those sensors are broadcasting. And there are other kind of security keys like that throughout the rest of the stack. And then there's a network feature around locationing, which, given that the sensors are communicating often to multiple gateways at one time, you can actually use triangulation and time of flight, to give an approximate location of that sensor. Might not be, pinpoint accurate, but allows you to at least determine, within a matter of feet or yards where that sensor is, whether it's in a building or out in the field. And if you're using locationing services over LoRaWAN, then there's no battery life impact, meaning you're not running a GPS function on the sensor that's chewing up your battery. So a great popular use case for LoRa locationing is in the agricultural space. Let's say you're doing cattle tracking. Obviously, you don't need to know exactly where that cow is. If you could get within 20 feet of it, you'll be able to see it. So set up 3 gateways throughout a farm, and you're able to determine, without any impact on the battery of the sensor, where all your cows are. So now we're going to talk about vertical markets. And then in the interest of time, I'm going to kind of step through each of these markets relatively quickly. And if anyone wants to do a deeper look at one particular market, because it's something that's maybe that's the space that you play in, please let Jen know in the chat, and she could stop me here and have me go a little bit deeper. But yeah, just to touch on some of the key vertical markets that LoRaWAN was designed for: healthcare, agriculture, industrial control, smart buildings, smart cities, environmental monitoring, metering, and supply chain and logistics. That's not at all an exhaustive look at the verticals. I've seen LoRaWAN play into just about every vertical market out there. But I would say that these are probably the 8 most common spaces where you see LoRa. So vertical deep dive again. Yeah, go ahead.
In the chat, there is somebody asking about MFG.
Manufacturing?
Yes.
Yeah, absolutely. I would kind of, kind of include that in the smart industrial control. But yes, there are many use cases for LoRaWAN inside the manufacturing world. And actually, the LoRaWAN manufacturer that I worked for, prior to working at CalChip, we were kind of eating our own dog food and in the process of converting our entire manufacturing facility into a LoRaWAN enabled manufacturing facility. All right, so again, I want to save room mostly for questions and discussion, so I'll go quickly through the verticals. I won't spend a lot of time on these slides, but stop me if you need me to. One of the early and still largest use cases for LoRaWAN was around metering. For connecting meters, typically they don't have electricity running to them. So the ability for metering companies to not have to do drive-bys and send technicians out to check meters, but to monitor them remotely. So you've got all sorts of meters talking back to gateways that the utility companies have deployed, and that data going into both the utility companies' software where they're monitoring and recording that, but also the utility companies could then share that data back very easily with their customers, whether that's through an application or printed on their bill. Smart healthcare, there's been a lot of LoRaWAN innovation in the healthcare field, a lot of it around different wearables. You see this device up here, CareBand, which was designed specifically for patients with dementia, who tend to either wander or have kind of erratic activity. So that's for monitoring dementia patients, but other wearables tracking other different vital signs in the healthcare industry. And then I would go beyond this to say that there's a lot of LoRaWAN deployments now within healthcare facilities. So everything from monitoring the temperatures of medicines or vaccines in hospitals to monitoring the location of beds, patient beds, and other high value assets in the hospital that tend to get misplaced or that people spend a lot of time having to look for if they are misplaced. Lots of innovation around smart agriculture. I mean, you can imagine you've got a farmer who's got thousands and thousands of acres. In order to keep track of exactly where they need to water and when, soil moisture sensors come in extremely handy. So everything from soil analysis, moisture sensing, coupled with valve control, actually controlling the irrigation valves, and as I mentioned before, tracking cattle and not just tracking their location, but also monitoring their health, determining if a cow has an early illness showing, so it can be separated from the herd before it infects the rest of the herd. Lots of stuff in industrial control. One of the most common use cases we see is monitoring of all sorts of levels, tank levels in silos, in sewage plants. I mean, anything that needs level sensing has probably, there's probably been a LoRaWAN deployment around it. Lots of temperature control, vibration, predictive maintenance. These are all some of the things that we're seeing in smart industrial control segment. Smart home and building. This is, as you can see, I mean, there's a lot of products on this page. There's a lot of areas that LoRaWAN plays into inside of smart buildings. Monitoring presence. Carbon dioxide has become a big thing in the past several years. Leak detection is huge, especially in the insurance space. Anything that you could see from a home security standpoint, door window monitoring, motion sensors, lighting sensors, the list goes on. I mean, because of the range of LoRaWAN technology, it makes a lot of sense in a smart building deployment. And then cities, LoRaWAN has been adopted both at the city level and by vendors who are supplying solutions to cities. If you do, a little internet searching, you can see actual cities that have adopted LoRaWAN and have done entire citywide deployments to manage their streetlights, parking use cases, city parking, and then city beautification as well, monitoring their waste bins so that they're optimizing, drivers' routes when emptying those waste bins. Given the strengths of LoRaWAN, you can see how it be grafted really well right onto a smart city deployment. Here's just some quick stats around the vertical market positions. You can see obviously that adoption is growing year over year, and then this little percentage here breaks down how much of each vertical is around asset tracking. So within each of the vertical markets, there's a heavy focus on where's my stuff, and that could be indoor, that could be outdoor, that could be a combination of indoor and outdoor. But generally, each market has some version of I have an asset and I want to know where it is, and so LoRaWAN solves that use case in a wide variety of ways. All right, we'll kind of skip over that. Okay, cool. I'm gonna take a breath here. Is there anything that anyone wanted to see more on the vertical side of things before we do a quick technical deep dive? Okay. All right, Jen, just pause me if someone chimes in on the verticals. Okay, I have to preface the technical deep dive by saying, right, I'm not the engineer on our team, but hopefully I can capture the stuff at a high level. I wanted to make this presentation more executive friendly. So for the engineers in the room, forgive me in advance. But hopefully this at least gives you a snapshot of what you would need to know when you're dealing with LoRaWAN technology. So going back, just a reminder of that high-level architecture, sensors to gateways to network servers to application servers that are then pushing that data into the various applications. That's all secured, and you can see here, how it is secured. A word about the network elements. So you've got the end device wirelessly connected to the gateways. The devices are assigned with several unique identifiers. Those are the keys that I talked about earlier. The identifiers are used for secure activation and administration of the device. You've got the LoRaWAN gateways relaying packets between multiple LoRaWAN endpoints and the network server. And I mentioned this before, there's no fixed association between a sensor and a specific gateway. Instead, the same sensor can be served by multiple gateways, which improves the RF network quality of service. Then the network server is the magic piece in the cloud. And I saw we have one of our friends from one of the most popular network servers on the call today, so thanks for joining. The network server manages the entire network and controls the network parameters through the system to changing conditions. That's actually that's a key point of LoRaWAN, is that the network is self-adapting all the time to optimize transmit powers and channel assignments and all that good stuff that you need in order to ensure that when you have millions of end nodes talking at the same time, that none of the messages getting sent by those end nodes are being dropped. The join server manages the over-the-air activation of the end devices, and then also processes requests. So when you activate a LoRa sensor, it sends a message up to, hey, I want to join. This is the network that I'm supposed to be on, and I want to join it. And then the join server validates that and sends a message back to the device that it has joined the network successfully. And then the application server responsible for handling the data, interpreting it, getting it to the right application and ultimately to the right customer.
Hey Brian, before you move on,
yeah,
there are two questions I think might be helpful if we go to the back of slide to answer. One is somebody asked, you said that one could be in a few LoRaWAN networks at a time. How does the sensor or device know which one to communicate with? And are the networks proprietary?
Those are all great questions. So you could have a device that is actually being heard by multiple LoRaWAN networks at the same time, but just like with your cell phone carrier, it would only be associated to one of those networks. So when you provision a device, you provision it onto a specific network, whether that's a private network or a public network. If the other networks are hearing your device, they're just discarding that data because that device is not registered on their network. So I think that's the first part of the question. What was the second part? Was about proprietary. So yeah, so you can deploy networks both that are totally private. So that would be like an enterprise or like a campus deployment where it's my network, my stuff that I'm monitoring, my sensors. So I don't want other people roaming on and leveraging that. Or you can deploy on public networks. And there's been a lot of effort in the LoRa Alliance over the past couple of years to work out roaming between public networks. And so we're already seeing roaming agreements that have gone into effect. So it's possible that even though you are registered and you're paying some annual fee, for your device to be on public network X, they might have a roaming agreement with public network Y, which just means that you get better coverage as you move from city to city or across the country. So hopefully I think that hit all aspects of that question.
Brian, you mentioned public and private networks. Could you quickly talk about the difference?
Yeah, so a private network would be one where again, I'll use the case of an enterprise, maybe that has a big campus, or like an oil and gas company that has a big oil field. They might deploy a network specifically for themselves. The only sensors on the network are sensors that have been deployed by the company that deployed that network, in their oil field or in their building or across their campus. So they're not opening that network up for other people to use nearby, their neighbors or other people who work in that same space. That would be a private network. A public network is a network that was deployed specifically for, again, I'll use the analogy of like like a Verizon or AT&T. There are public LoRaWAN network operators who have deployed networks, deployed gateways for anyone to use. In which case, if your use case, if your application falls within the footprint of that network, rather than you having to deploy infrastructure, you just be able to hop on the public network. And yes, there's you pay a toll for that, but it's nothing like cellular data. And of course, the lawn guy had to show up in the middle of the webinar. Okay, Jen, let me know if you're hearing the background noise. I can switch to a headset here.
You're okay so far.
Okay, cool. Work from home, the joys of work from home. Okay, so did that hopefully that answered public and private and the difference. I think it did before I got interrupted. Okay, just to talk a bit about, you've got 3 different device classes. Majority of what you see out there is device class A. That's your typical battery operated sensor that's, going to sleep, waking up, sending out just a little packet of data, going back to sleep. And when I say little packet, I mean like 11 byte packet. These are, LoRaWAN is made for small amounts of data. You're not streaming Netflix over the LoRaWAN protocol. So class A devices, the majority of what you see out there, soil moisture sensors, temperature sensors, water meters, etc. Then I'll skip to class C, which is continuous transmission. That usually has to do because there's an actuator component. You're actually controlling something on a device and you don't want any latency. So you need that device to be always on, always listening for commands from the network telling it to do something. So generally those are powered. Those are sensors that are plugged in. A great example would be a smart outlet or smart plug. So obviously the plug is getting its power from the power outlet, and then you can control that smart plug over LoRaWAN. Street lighting is another good example of that. And then then class B is somewhere in between, where you're able to get downlinks, but latency is not an issue. You can afford to wait a couple of minutes before taking that command. So something like a water shutoff valve in a field, where it's not necessary that, hey, within half a second the valve shuts off. When you want it to, it can go a couple of minutes, and therefore you can actually do battery operated actuating with a class B device. Class B is something that is relatively new as far as like the number of sensors that are being built in class B, but they're becoming more popular now. Okay. Do we want to talk about LoRa Edge? This is okay. I'm going to skip over this, maybe come back to it. To touch on different types of deployments, which we started to talk about when we were talking about public versus private, single gateways versus multiple gateways. So LoRaWAN supports many different types of deployments. On the simplest scenario, you've got a single site with a single gateway, creating a private network in that building, and all the devices talking to that one gateway, which is then backhauling the data to the cloud. Then you could have multiple sites, each with a single gateway. Great example would be, a restaurant chain, where you might have temperature sensors or motion sensors, door sensors in that restaurant, broadcasting back to a single gateway. But something to note is, together, even if these restaurants are spread out across the country, they kind of make up their own network, specific to that fast food chain. Then you've got the example that I use, like a campus that's got multiple gateways. And that would typically also be a private deployment where the only people using that network are on that campus. It's being used by the company that deployed the infrastructure. And then you've got the big public multi-site, multi-network roaming, and this is ultimately the dream. I wouldn't say it's the dream, it's the reality of LoRaWAN. You've got multiple networks now, covering a large portion of the globe, where anyone can use those networks, and now you can roam between networks. So this just opens up so many possibilities for various IoT use cases. I might come back to these during the Q&A to use these to answer questions, but this just kind of goes a little bit deeper into, single site, single gateway example. Something to mention here, if it's a single site with a single gateway, it's possible that all of the network software and the application software could just run on that gateway. You don't need a cloud component necessarily when you're doing single site, single gateway. So this could be a very closed off ecosystem, which obviously increases security. Not that the cloud's unsecure, but just creates the illusion of more security because it's all staying on premise. And then that gateway is talking to whatever data server is in that building. Okay, and then you could do a single site, single gateway where it's still sending data up to a network server, an application server, and joint server that's in the cloud. That's totally cool too. That's generally what most people do. Most people, I don't know if I can speak for most people, but what I've seen, most people aren't running local network servers, application servers, because that requires some amount of coding and configuration of the gateway beyond that wouldn't be running that gateway in what's called packet forwarder mode, which is really the gateway's listening and then sending those packets up to the cloud where all the intelligence lives. But for certain use cases, sorry, going back to the slide, for certain use cases, having the intelligence at the edge, having the intelligence on the gateway is required for the use case. That could be because of an exorbitant amount of data that's going into that gateway, but we don't want all that data being sent to the cloud or sent to the servers. So there are reasons to deploy local kind of a local network running on the gateway. But I would say by and large, vast majority, the gateway is passing that data up into the cloud, and then all the magic's happening once it gets to the network server. Okay, again, might come back to these depending on where the questions go. This has just got some cool talking points when it comes to covering large areas. As I said before, the network's self-optimized to expand and reinforce the RF coverage. Every time you add a new gateway to a network, there's no complicated tuning or local configuration needed. LoRaWAN just works. If you're deploying your own network, you might leverage a variety of backhauls. You could have some gateways that are running cellular backhaul because of where they're placed. Maybe they're placed on top of a grain silo that doesn't have power, so you're going to use, that doesn't have Ethernet, so you're going to use cellular backhaul. I've seen gateways placed in where they don't have power, so they're actually running the gateway off of solar and backhauling over a cellular network. All powered by a solar panel. And then we touched on this. All LoRaWAN endpoints, inherently enable indoor outdoor geolocation without GPS. But you need to have a slightly denser network in order for that to be really accurate. Okay, and technical deep dive. So, how to design a LoRaWAN solution. This is kind of a sum total of everything we've talked about. You identify the best hardware options. You choose your connectivity, which is what network server you're going to be running off of, and then what backhaul option, and then ultimately that data needs to go into some sort of application. There are plenty of pre-designed applications out there. They're generally referred to as IoT platforms. There are plenty of companies that design IoT applications to be kind of the front end of a solution. But in general, you need to make decisions about every point in the stack. One of the pros and cons of LoRaWAN is that it's this massive multi-source value chain. So for each portion of the stack, there are many, many ecosystem players designing specifically for that portion of the stack. Now, that's a good thing in that it gives you, as the solution designer, many options. It's a bad thing because it gives you, as the solution designer, many options. It can oftentimes be a little overwhelming to sort through that. But as you can see on the slide, there are many well-known companies that play in LoRaWAN space, the likes of Honeywell and Murata and Machine Q is a Comcast company, Google, and Amazon Web Services. So some pretty big household names that have adopted portions of the LoRaWAN stack that they've designed and launched. And then just a quick mention over here. There's a unique network out there in the world that we're heavily involved in. I just want to mention it. It's the Helium Network. In case you're reading about that, Helium is a combination of blockchain and cryptocurrency incentives to get people to deploy LoRaWAN gateways. And they've actually been very successful in deploying a global LoRaWAN network by incentivizing people using cryptocurrency we're going to see cryptocurrency and crypto tokens used a lot more in IoT as incentivizing people to not just deploy networks, but also to deploy sensors. Again, if you have questions about that, we can cover it a bit in the Q&A. Gosh, I am so long-winded today, and I want to leave time for questions. So I'm going to burn through this stuff really quick, even though this is kind of the meat of the presentation. So forgive me for that, but I want to make sure to address your questions. So there's some problems with the current customer journey. Yes, it's transforming technology. Yes, there's that large ecosystem of vendors, but generally, because of the choices that you have out there, there tends to be a lot of work needed in order for you to deploy a simple proof of concept. Part of that's because each of those ecosystem vendors, majority of them are just making one portion of the stack, so you need to combine all the portions of the stack in order to get a full end-to-end solution. Now, there are vendors out there who have mastered multiple portions of the stack, and they can provide you with more of a turnkey solution. But one of the issues with IoT in general, which you all know, is that there really is no one-size-fits-all. So you might find an existing end-to-end solution that's really close to your use case, but ultimately it's going to need some tweaking to like perfectly fit you and your business or your customer profile. And so because of that, there's generally some, there's a long R&D cycle that needs to go into it. You're generally working with multiple vendors and you have to manage, agreements with them in terms and conditions. So that's one of the things that you'll run into if you're just getting into LoRaWAN for the first time. And this kind of recaptures that pitfall. Customer, I think that LoRaWAN might solve my problem. They search the internet. They find a bunch of companies that make different portions of the stack. Unfortunately, those companies then introduce them to other companies that make the same portions of the stack. And so, the customer's world becomes kind of a spaghetti mess of different vendors and agreements. And here's what your desk looks like after 6 months. And for a lot of customers, that can lead to fatigue. That can lead to, hey, this is more complicated than I thought it was going to be, and I want to walk away from using LoRaWAN. That's the whole reason that we started CalChip Connect, was to solve that problem. So when a customer engages with us, we're able to deliver a full stack solution very quickly because we're representing as a value-added distributor the entire LoRaWAN ecosystem. So we're able to pick the best in breed hardware, the right connectivity, and bring that forward to the customer without you or your customers having to go through any sort of complicated R&D cycle. This is just my shameless plug for working with CalChip Connect. I'll skip the example story, but the main point of this company, Crisis Go, they were a software company. They wanted to have a physical panic button that they could deploy in schools. And they spent 4 years trying to figure out the right technology to use, the right hardware to use, the right vendors to work with. I know they spent 4 years because they were my customer 2 companies ago. And then I re-engaged with them when I got to CalChip. And because we're an aggregator of the entire ecosystem, we were able to deliver an end-to-end solution to them. They launched nationwide, 3 months after we started working with them. But yeah, there's benefit to working with an IoT consultant or a vendor that has a lot of experience in the LoRaWAN space, so that they can kind of coach you through the decisions that you have to make. Oh yeah, that was the solution that Crisis Go was able to put out. They call it the safety one-click solution, and it's a panic button for crisis situations in schools. Okay, some other advice, and then well, unfortunately, what I didn't want to do was leave 3 minutes for questions, but that's what we're going to have. Be on the lookout for vendor lock-in. As you engage with vendors, like everyone wants to be sticky, and so you got to. LoRaWAN is an open technology. You should be able to swap out different portions of the stack if you're not happy with the vendor that you're working with. So you just have to have your radar up that some vendors, not all, but there are bad actors out there who want to get you stuck into their portion of the stack and not let you leave. So be on the lookout for that. Remember that there is a difference between LoRa and LoRaWAN. Someone might have a LoRa solution that is proprietary and will not interoperate with other sensors. So now some people, unfortunately, they casually use the term LoRa when they're really referring to LoRaWAN. So if someone does mention LoRa, period, just LORA, then you do have to ask, is that proprietary? Is it using the LoRaWAN protocol? My other advice would be, if you're interested in getting started, just start. You can get really bogged down in researching all the options, but it's not that difficult to put a proof of concept together and just get something out there in the field, and then you can adjust, while the train is in motion. Stay ahead of the supply chain. That wasn't on my slide 2 years ago, but it is now. You're all aware of the supply chain crisis. Generally, for whatever your use case is, there is a sensor for that somewhere in the world. Some company has made a sensor, a LoRaWAN sensor for that. And if it's such a niche use case that there's not a sensor out there, then the LoRaWAN design houses, as we call them, companies that are making custom sensors, they're really affordable. And we at CalChip can connect you to design house, again, if the sensor that you're looking for doesn't exist. Okay, we got 3 minutes left. Jen, what are the most awesome questions that have showed up in the chat?
Oh, wow, that was fantastic. Thank you so much, Brian. I'm now going to open the floor to questions from the chat window, and I'm going to start from the top. Let's see. First question is, someone is implementing LoRa point-to-point and mesh based on sensors today. What am I missing out by not using LoRaWAN?
Oh, man, there's some people on the call better qualified to answer that. Interoperability, being able to expand that solution very easily to cover other use cases. And then I'm not sure if what the packet drop rate is in that point-to-point solution, but if it's not architected and deployed perfectly, then yeah, you might run into issues that you wouldn't run into if you were using LoRaWAN. Point-to-point is just a bit more tricky, but yeah, expanding outside of that use case then is not really an option for you. Generally, LoRaWAN is a land and expand type deployment. You start with one use case, and that's your impetus for getting your infrastructure, your gateways in place. But then you can grow beyond that and start deploying other adjacent use cases. You can invite other people to use that network. So the growth opportunity, I think, is really what you're missing in that deployment.
Next question is for discrete manufacturers in low vol high mix industrial space. Do you see more growth with LoRaWAN in fluid process applications?
I was with that question right until fluid process applications. I would need further clarification on what that seemed to be core to it. If you could clarify what fluid process applications means. Sorry.
Industrial fluids.
Oh, industrial fluids. Oh, actual fluids.
Mm-hmm.
Okay, and then the question being,
do you see more
I tell you
growth?
what, that was so specific. Yeah, let's take that one offline. Actually,
okay.
Yeah, I'd love to have a follow-up with whoever's asking that and get my engineers in touch.
And then let's see. Final question is, if you establish a LoRaWAN private network in a remote location with no internet or mobile access, the next mobile access is about 15 miles away. What are the ways that you can take your data to the cloud?
Okay, so we're in a remote location, no internet access. 15 miles away. Gosh, I mean, because it's possible to get that LoRaWAN cranking, and you could potentially hop that, put a gateway or two in between where you have internet and where you have the deployment. So you could send the data from gateway to gateway till you get to your internet takeout point. That's one way to do it over all LoRaWAN. There are probably some other technologies that might solve that, beam forming over other radio frequencies, but If you want to do it with LoRa, and we've seen this done on like railroad deployments, where sensors are communicating the gateways are then hopping that. And if you had no power, you would use solar power gateways. That was a decent answer to that. All right, we're at time. I'm sorry, I want to leave like 15 minutes for discussion. This is awful, my bad, but hopefully the stuff that I did say was super valuable. And I just appreciate everyone being here and giving us your time today.
Thank you again, Brian. This was a wonderful presentation, and I hope that everyone has a great rest of your day. We'll see you later. Thanks.
Cool. Take care, all.